Inductive reasoning with sequences. Okay, sequences is a common, popular way to use inductive reasoning because you see the first few numbers and you use inductive thinking to look for a pattern or relationship between the numbers enough to predict what the next number would be. All right, let's look at a few examples. First one says 1, 4, 7, 10, and we have to say what the next number should be using inductive reasoning. We never can say for 100% sure, but if we see enough of a pattern, we can be pretty sure what the next number should be. But let's see what we got here. 1, 4, 7, 10. Well, from 1 to 4, I could be multiplying by 4, but 4 to 7 doesn't work there. Let's look at addition. 1 plus 3, 4 plus 3, 7 plus 3 is 10. So it sure looks like they're adding 3 every time. We can't be sure. There could be some very complicated pattern, but the way it looks, the number coming up would be 13. Okay, this is called inductive reasoning because we never know for sure, but we can feel pretty certain about what we're observing. All right, 1, 3, 6, 10. Well, ends in 10 again, but am I adding 2? 3 times 2 is 6, but there's no multiplication working here, so I add 2, I add 3, I add 4. My guess would be we add 5 the next time and get 15. So we don't know for sure, but again, that's inductive reasoning, looking for these patterns. What's happening here? 2 times 3 is 6, times 3 is 18, and so on. Again, most likely we're timesing by 3, 5, 6, 8, 11. What's our pattern? Well, we're adding 1, adding 2, adding 3, and so on. So we're probably adding 4, adding 3, adding 5, adding 7, so adding 9. So the amount we're adding goes up by 2 each time. And finally here, this one's going down. So it looks like that's half, half, half is 16, and so the next number should be 8. Okay, so this is looking at sequences. We're using inductive reasoning because we're never 100% sure, but usually the pattern becomes somewhat predictable too.